Hello everyone. Last time we went over what really is a quadratic equation, and now I'm going to be going over how you can solve these equations. Now, if you look at one of these in standard form, you'll realize very soon that x squared and x seem like two different variables. You can't collapse them down to one variable like you would when there's no x squared. Therefore, the easiest way you would think of doing this is to turn the x squared somehow into two x's times together, right? Since x squared is just x times x. And since we have this thing equals 0, if we can turn this equation into something in like the forms of a times b equals 0, then we'll be able to know that either a equals 0 or b equals 0, or both. So therefore, if we can turn it into something if we can turn something like this, ax squared plus bx plus c, into something like this, px plus q times mx plus n, in which if you try to use FOIL on it, you get pmx squared plus mqx plus pnx plus qn, you'll be able to get that px plus q is what we define as a, and mx plus n is what we define as b. Therefore, if we come back to this original standard form equation, ax squared plus bx plus c equals 0, then we can turn it into something that looks like this. Px plus q times mx plus n is 0. And therefore, since we know that since if we define px plus q as a and mx plus n is b, then a times b is 0. So a or b is 0, which would mean that either px plus q is 0 or mx plus n is 0. Therefore, if you think about it, we just turned something that has an x squared into two equations without x squareds, which both should be solvable, which would then lead to x1 being negative q over p and x2 being negative n over m. Therefore, from what we have seen in our example, how we can solve these equations is first to take whatever we have been given and then turn them into something that looks at least slightly like standard form. And unlike when you would solve equations that didn't have an x squared, you would have to, instead of isolating the x, you have to isolate a 0 on one side. Since as you can see, using this, we use the sort of property of 0, where if two numbers multiply to 0, that would mean that one of them must be a 0. Therefore, after that, we can then factorize to get something times something, like in this case, px plus q times mx plus n is 0. There has to be nothing else left, or therefore we'll have something else that's not 0 on the other side. And then you can just solve the linear equations of which px plus q is 0 and mx plus n is also 0. Now let's look at an example. 4 times x plus squared 4 times x plus 2 times x minus 3 equals x minus 3 squared. Now, the most simplest and most straightforward way you could do this is just by simplifying it down by using FOIL on both sides to get 4 times x squared minus x minus 6 equals x squared minus 6x plus 9. And then you can just continue to simplify to get 3x squared plus 2x minus 33 is 0, and then factor this, in which case you'll see it being used directly. 3x plus 11 times x minus 3 equals 0. And if you use FOIL on this 3x plus 11 times x minus 3, you realize that indeed this does lead to 3x squared plus 2x minus 33. Well, how does this happen exactly? Well, if you look at the two coefficients in front of x, those two coefficients would times up to the coefficient before the x squared, and then the two constants in these two expressions would multiply to the constant in the original equation. However, the coefficient before the x is a little bit more complex because it's the coefficient of the first x in our two expressions times the constant in the second expression plus the constant in the first expression times the coefficient before the x in the second expression. Basically, FOIL. So basically, factoring is sort of reverse FOIL, in which you can get this. And then it's just solving these two equations, 3x plus 11 equals 0, or x minus 3 is 0. Therefore, yielding that x1 is negative 11 over 3, or x and x2 is 3. However, the astute among you might have realized that you could divide, it looks like you can divide both sides by x minus 3, since both sides have x minus 3 and they're all one single multiplied expression. But can we actually do this? Pause the video now if you want to think about this and just maybe try it out yourself. Now, if you've tried this, you'll realize that you only get the answer that x equals 3, but not the answer that, no, only the answer that x equals negative 11 over 3, but not the answer that x equals 3. Now, here's the reason. If, in any case, x equals 3, then x minus 3 would be 0. Then that would mean that when you divide by x minus 3, you're dividing by 0 and the universe implodes on itself. Therefore, to make sure that this does not happen again, you can say that when x equals minus 3 is 0, then x equals 3, and if you actually substitute x equals 3 into the equation, you realize that that is indeed a solution, therefore you can include the solution. And also when x equals minus 3 is not 0, therefore meaning that you can actually divide by x minus 3, you get that 4 times x plus 2 is x minus 3, which would then yield 3x plus 11 equals 0, which would then simplify to x equals negative 11 over 3. Both of these solutions are correct, and both of these solutions are actually viable for this quadratic equation. Our last method is basically to subtract both sides by x minus 3 to get 4 times x plus 2 times x minus 3 minus x minus 3 squared, and then sort of just use something that's like the reverse of the distributed property to get that x minus 3 times 4 times x plus 2 minus x minus 3 is 0, and then you can simplify 4 times x plus 2 minus x minus 3 to get 3x plus 11, which is actually the exact same as the two expressions that we had simplified before in our first method, which would then lead to the same two expressions, which would then lead to the same two solutions that we would usually get from the other two methods. Now that I've explained one example for how you could do this, you can also pause the video now and just try out these three, see if you can solve them. Now here are the solutions for the three questions put here. Now check your answers and see if you got them right. Thank you for tuning into this little session, and goodbye.